Same thing with division. So we're going to look at 6 is less than 10. 6 is less than 10. We can agree that that's true right now. So we're going to divide both sides of the inequality by 2. I'm going to show my division as a fraction because every fraction is a division problem. So 6 divided by 2 gives me 3. 10 divided by 2 gives me 5. 3 is less than 5. That is true. That checks out. We're going to start with that same inequality. 6 is less than 10. We can agree that that's true right now. We're actually going to divide both sides by -2 now. Again, I'm showing my division as a fraction because every fraction represents a division problem. So 6 divided by -2 gives me -3. 10 divided by -2 gives me -5. And if I were to just carry this down, -3 is actually not less than -5. -3 is greater than -5. So again, we're going to note that we divided both sides by a negative number, and I end up needing to change and flip that inequality symbol for the inequality to still be true. So now we're going to look at some problems, some inequalities that we're going to be solving. And we're going to use those patterns that we just noticed. So the examples where we had to multiply or divide by a positive number, we did not need to flip our inequality symbol. We could leave it the same. But the problems where we multiplied or divided by a negative, we needed to flip the inequality symbol to be true. So here I have 3x is greater than 15. Right now x is being multiplied by 3, so I want to undo that by dividing by 3. Over here, my 3's will 1 out, so 3 divided by 3 is 1, leaving me with x. 15 divided by 3 is 5, and because I divided by a positive number, I can just carry down that inequality symbol, so I get x is greater than 5. The graph of this, remember we just need our 3 numbers. I'm going to have an open circle at 5, and then my arrow would be to the right, okay? I can plug in a value now just to test my solution and make sure it works. So I can plug in any number greater than 5, so I'm just going to go ahead and plug in a 6. So let's plug in and check. So my original inequality was 3x is greater than 15. I want to test 6 now. So 3 times 6 is 18. 18 is greater than 15, so that checks out. Now we're going to do that same inequality, but this time we're dividing by a -3. So -3x is greater than 15. So x is being multiplied by -3. So to undo multiplying by -3, I'm going to divide by -3. On our previous examples, when I multiplied or divided by a negative number on both sides, that's when I had to flip the inequality symbol to be true. So -3x divided by -3, my -3's will 1 out, leaving me with x. And then 15 divided by -3 is -5. And then because I'm dividing both sides by a negative number, I'm actually going to end up flipping my inequality symbol to be less than. So we get x is less than -5. The graph, I'm going to put my -5. I want an open circle because it's not actually equal to -5. And then all values less than -5 are going to be to the left. And again, I can test this out. So because my arrow is going toward this -6, let's just plug that one in. So my inequality is -3x is greater than 15. I'm going to plug in -6. So -3 times -6. And -3 times -6 is, just kidding, positive 18. And 18 is greater than 15. If you had forgotten to flip your inequality, so let's say you kept it as x is greater than -5, then you would be plugging in -4. And when you do that, Negative 3 times negative 4 would be positive 12, and positive 12, you would end up with 12 is greater than 15, which is not true. So then that would mean that your arrow needs to go the opposite way. Here, solve and graph the inequality. 4y is greater than or equal to negative 18. So y is being multiplied by 4, so I'm going to divide both sides by 4. Now, we want to pay attention to what we're dividing by. So here I'm dividing by a positive 4. 4y divided by 4, the 4 is 1 out, leaving me with y. And then on this side, there is a negative in the problem, but the actual number I'm dividing by is positive. So even though I know I'm going to end up with a negative answer when I divide, the number I divided by was positive. So then this actually, I can keep my inequality symbol the same direction right now. So I'm going to do negative 18 divided by 4, which would be negative 4.5, or you could write that as negative 4.5. Since y is greater than or equal to that value, that means it's going to be a closed circle. Because it can be equal to it. And then all the values greater than that are going to be over here to the right. So when I plug something in, for example, I could plug in that negative 4. And if I do 4, y is greater than or equal to negative 18. So 4 times negative 4 is going to be negative 16. And negative 16 is indeed greater than or equal to negative 18. All right, same thing is true with some division problems. So here we have w is divided by 5 to be less than negative 3. W is being divided by 5, so I want to undo that by multiplying by 5. As a reminder, when I multiply the left-hand side with the variable by 5, what's really happening here is I end up with 5w divided by 5, where my 5's end up 1ing out, leaving me with w alone. All right. And then on the right-hand side, negative 3 times 5 gives me negative 15. So I'm going to go ahead and bring that part down. Now, the number I actually multiplied both sides by here was a positive 5, so I can keep my inequality the same, and so w has to be less than negative 15 for this inequality to be true. So that means I'm going to have an open circle at negative 15 and an arrow to the left. Here's another one with division. So h divided by negative 6 is less than 5. I want to undo the dividing by negative 6, so I end up multiplying both sides by negative 6. 5 times negative 6 will give me negative 30. What's happening on the left side with my variable is I get negative 6h divided by negative 6. Again, the negative 6 divided by negative 6, those 1 out, just leaving me with h. So now I'm comparing h with negative 30. This is another example where I multiplied both sides by a negative number. So I actually have to flip my inequality for it to be true. So h has to be greater than negative 30 for this inequality to be true. The graph of this would be an open circle at negative 30, and then all values greater than that would be to the right. Okay, and so if I wanted to take any value greater than negative 30, one that's really easy for me to think of is 0. I can test that out. So 0 divided by negative 6 should be less than 5. 0 divided by negative 6 is 0, and 0 is less than 5. When we get to two-step inequalities, we're going to follow our same process for equations, solving two-step equations. So we want to undo the equation in the opposite order of operations. So when I look at this, my variable was multiplied by 4 and then I added 7, so I'm going to undo, the first thing I'm undoing here is that adding 7. So I'm going to subtract 7 from both sides. Over here with the variable, the 7's zero out, that positive 7 and negative 7. So I'm left with 4k is greater than 20. Right now k is being multiplied by 4. I undo that by dividing by 4. My 4 is 1 out, so k is greater than 5. This would be an open circle at 5. Arrow to the right. And again, I should be able to plug in any number to the right of 5 that's greater than 5, and my inequality should be true. So let's just go ahead and try 6. So 4 times 6 plus 7 should be greater than 27. 4 times 6 is 24, plus 7 is going to be 31. 31 is greater than 27. So this checks out. Here's another one where we have a two-step. So negative 2e plus 14 is less than negative 36. So my first step, I want to subtract 14 from both sides. Over here, my 14s will zero out. Negative 36 and negative 14 gives me negative 50. And now I'm to a point where I have negative 2e is less than negative 50. So from here, to get my variable by itself, e is being multiplied by negative 2, so I need to divide both sides by negative 2. My negative 2's 1 out, leaving me with e. Negative 50 divided by negative 2 is 25. And then because I divided both sides by a negative number, I flip my inequality symbol for it to be true. So e has to be greater than 25. So this would be an open circle, my arrow to the right, and I can plug in any number greater than 25 and test it out. So if we plugged in 26, negative 2 times 26 plus 14 should be less than negative 36. Negative 2 times 26 is going to be negative 52. Negative 52 plus 14 would be negative 38. And negative 38 is less than negative 36. We're going to do one with the distributive property here. Remember, on a problem like this, you have two options. You could either, since it's 3 times the 2y minus 5, you could either divide by the 3 right away, or you can distribute the 3 first, okay? Either way works. I'm going to actually work this one out by dividing by the 3 first. So if I divide this side by 3 and that side by 3, I'm going to get negative 13. My 3's 1 out, so I'm left with 2y minus 5 is greater than or equal to negative 13. Now I would want to add 5 to both sides. So negative 13 plus 5 gives me negative 8. Over here, my 5's zeroed out, so I'm left with 2y. And now I can divide by 2 to get negative 4. I divided by a positive number, so I don't need to flip my inequality symbol. So y is greater than or equal to negative 4 would be my solution.